The image depicts different methods of Doppler creation, illustrating how the Doppler effect can be measured depending on which elements, transmitter, receiver, reflector, are in motion. The Doppler effect refers to the change in frequency or wavelength of a wave in relation to an observer moving relative to the wave source. Each panel in the image represents a distinct scenario of movement affecting the Doppler measurement. Top left, transmitter moving. Scenario. The transmitter, such as an aircraft, is moving, while the receiver, on the ground, and the reflector are stationary. Description. The transmitter sends out a signal as it moves. This movement causes a shift in the frequency of the transmitted signal due to the Doppler effect. Measurement. The surface-based electronic support measures, ESM, or radar warning receiver, RWR, measures the Doppler shift. Doppler change. One-way Doppler change, as the shift is only due to the motion of the transmitter. Top right, receiver moving. Scenario. The receiver, such as an aircraft, is moving, while the transmitter and reflector are stationary. Description. The transmitter sends out a signal, which is reflected back to the moving receiver. The movement of the receiver causes a change in the frequency of the received signal. Measurement. The airborne ESM or RWR measures the Doppler shift. Doppler change. One-way Doppler change, as the shift is only due to the motion of the receiver. Bottom left, reflector moving. Scenario. The reflector, such as another aircraft or object, is moving, while both the transmitter and receiver are stationary. Description. The transmitter sends out a signal, which is reflected off the moving reflector. The movement of the reflector causes a change in the frequency of the reflected signal. Measurement. The surface-based radar measures the Doppler shift. Doppler change, two-way Doppler change, as the signal is affected twice. Once when it hits the moving reflector and again when it returns to the receiver. Bottom right, all three moving. Scenario. The transmitter, receiver, and reflector are all moving. Description. The transmitter sends out a signal, which is reflected off a moving reflector and received by a moving receiver. Measurement. The airborne radar measures the Doppler shift. Doppler change, two-way Doppler change, as the signal is affected multiple times by the movements of the transmitter, reflector, and receiver. Summary. Transmitter moving, top left Doppler shift due to the movement of the transmitter, measured by a stationary receiver, one-way Doppler. Receiver moving, top right Doppler shift due to the movement of the receiver, measured by the receiver itself, one-way Doppler. Reflector moving, bottom left Doppler shift due to the movement of the reflector, measured by a stationary receiver, two-way Doppler. All three moving, bottom right Doppler shift due to the movements of the transmitter, reflector, and receiver, measured by the receiver, two-way Doppler. This detailed breakdown shows how the Doppler effect can be influenced by the motion of different components in a radar system, which is critical for accurate measurement and interpretation in various applications like aviation, meteorology, and military surveillance.